April 2, 2020, the East Tokamak in Hefei controlled nuclear fusion experimental device achieved for the first time 100 million degrees Celsius stable operation for 10 seconds. This achievement, meaning, brought human civilization closer to successfully achieving controlled nuclear fusion. One step closer. But currently, the highest artificial temperature is not 100 million degrees Celsius. But in 2012, high-energy physicists, 5.5 trillion degrees Celsius generated by accelerators. In physics, temperature is the external manifestation of particle motion speed, not the macroscopic temperature we feel. Because of this, individual particles in accelerators can achieve ultra-high temperatures of 5.5 trillion degrees Celsius without affecting the macroscopic world. Compared, humans have made great strides in creating high temperatures. The path to creating low temperatures is much shorter. Therefore, in our universe, the lowest temperature is minus 273.15 degrees Celsius. This is called absolute zero. These two numbers, minus 273.15 and 5.5 trillion, make the latter seem more difficult than the former. But in physics, the former is like the speed of light. You can only approach it infinitely, but can never reach it. So the question arises, why can humans never reach absolute zero? This question involves the essence of temperature. As we mentioned earlier, temperature exists because of particle motion. So as long as particles are moving, temperature is generated accordingly. Therefore, to achieve absolute zero, first we need to stop all particle motion. But quantum mechanics has an uncertainty principle, which roughly states, microscopic particles like electrons outside the nucleus, position and momentum cannot be determined simultaneously. Scientists can only describe them using probability. Since all matter is composed of atoms, and atoms are composed of electrons and nuclei, cannot locate electrons. We cannot stop electrons. Therefore, electrons will continue moving, and motion brings heat. Although this heat is extremely weak, but it indeed prevents absolute zero from occurring. Currently, physicists use laser cooling in laboratories. Generated low temperatures of 0.5 nanokelvin, only a 200,000th K above absolute zero. Although so close to absolute zero, physicists understand they cannot reach absolute zero. Just like objects with rest mass cannot reach the speed of light. In quantum mechanics, while preventing humans from achieving absolute zero, relativity also prevents humans from achieving maximum temperature. If absolute zero is the absolute stillness of particles, so maximum temperature is the upper limit of particle motion speed, which is the speed of light, but among microscopic particles except photons, all others have rest mass, so they cannot reach the speed of light. Thus, the actual manifestation of maximum temperature is particles infinitely approaching the speed of light, and infinity clearly has no end. So maximum temperature also has no end.